Let's talk about conservation of mass in chemical reactions. In a chemical reaction, the atoms in the reactant, or the starting material, are rearranged to form new substances called the products, which are your ending material. So, for instance, maybe your reactants are the ingredients to make cake, and then in baking the cake, a chemical reaction occurs and you end up producing a cake. The number and types of atoms that you start with in the reactants are the exact same as the ones in the products. They're just rearranged to form a different substance. So let's say, for example, you have a Lego kit at home and your sibling has used all those Legos to build a castle. Well, you could take all those Legos apart and build a car, but you still have the exact same types of Legos that were in the castle and the same number of Legos that were in the castle. You just rearrange them to form something new. And the same thing happens with chemical reactions. Because atoms are too small to see, and so are molecules, scientists use chemical formulas and molecular models to show the types and number of atoms in a molecule. So here we can see these are ball and stick molecular models showing hydrogen, water, and oxygen molecules. And you can see that the chemical formula lets you know which atoms are in each molecule and which types, how many of each type there are. So for instance, for the water molecule, it says H2O. The little 2 subscript lets us know that there's 2 hydrogen atoms and 1 oxygen atom in this molecule of water, H2O. In hydrogen gas, it says H2, so that tells us that the atoms in this molecule are hydrogen and there are 2 of them. And then for the oxygen molecule O2, we can see that the type is O for oxygen, and again, there's 2 of them. In every chemical reaction, conservation of mass occurs. Let's talk about what this means. Every atom has a specific mass, and it's the same for all atoms of that type. So if you were to weigh a hydrogen atom, it would always weigh 1 atomic mass unit. If you weighed an oxygen atom, it would always weigh 16 atomic mass units. And it doesn't matter where you found that hydrogen atom, whether it was in a star or in a pond or wherever, it would always have a mass of 1 atomic mass unit. And any oxygen atom that you find anywhere in the universe would always have a mass of 16. Even when the substance changed to something new, the total number of atoms and their mass remain the same. So basically, you don't lose any atoms when you do a chemical reaction. They stay constant. And this is called the law of conservation of matter, or the law of conservation of mass. And it just means that you do not lose or gain atoms during a chemical reaction. They're just rearranged like those Lego pieces to make new substances. And so we can show that by making balanced chemical equations. It shows us that the number of atoms and the types of atoms we start with in a chemical reaction, the reactants, will always be the same and weigh the same as the number and types that we get in the products. So let's say, for instance, that we are going to combine 2 hydrogen molecules with 1 oxygen molecule to make 2 water molecules. Well, you can see in the reactant side, what we start with, I have a total of 1, 2, 3, 4 hydrogen molecules. And over here, hydrogen atoms. 1, 2, 3, 4 hydrogen atoms. And then over here, you can see that there are still 1, 2, 3, 4 hydrogen atoms. On the reactant side as well, I have 1, 2 oxygen atoms. And on the product side, I have 1, 2 oxygen atoms. So the number and types of atoms and their mass stay conserved. Law of conservation of mass or matter. Thank you so much for watching this video.